Hi children, good morning. Welcome back to our session. What's our topic? Light, reflection and refraction. We have known about the reflection of the light, and today's class we are going to see about refraction by the spherical lenses. Refraction by the spherical lenses. Have you observed in the watch shops, children? To repair the watches and all, they used to wear a small lenses here and they'll be watching like this. Is it? Yes. And few of the children will say, ma'am, I cannot sit in the last desk because I can't see the board clear. There, they'll wear the spectacles. Is it? In that spectacles also, some children will wear very thick one. Is it? Yes. Then, magnifying glass. The old people, they'll see the newspaper by using of the magnifying glass. Is it? What and all these are? These only we call it as the lenses. Okay? Then what do you mean by the lens? How we can see with that? How many types are there? These and all we are going to learn now. Let me see. What do you mean by lens? A lens is a piece of, what do you mean by lens? A lens is a piece of refracting medium bounded by two surfaces, at least one of which is curved surface. So here, what is that? A lens is a piece of refracting medium bounded by two surfaces. It will be having the two surfaces. In these two surfaces, at least one surface should be curved surface. Then only we call it as a lens. The commonly used lenses are the spherical lenses, which have either both surfaces spherical or one spherical and the other will be the plain one. So, we are using the spherical lenses only. In this, either both surfaces will be in the spherical or one spherical and the other will be the plain one. And in this, we are having the two types of lenses, that is the convex lens and the concave lens. Now, let me study about this concave lens and the convex lens. So, this lens is called as the convex lens and this lens is called as the concave lens. Now let me see children, these are called as the edges. So this is called as the edge. How is the edge? Here the edge is thin or thick, and in this it is the thin or thick. So the edge is here thin. And here, in this case, it is thick. And see the middle one, how it is? It is thin. It is thick, children. Sorry. The middle, it is having the thick one. And here, it is very thin. So, what we can say? For the convex lens, the middle part will be having the thick and the edge will be the thin. And what about in the concave lens? The middle part will be thin and the edge part will be the thick one. Is it? Yes. So, when we draw a line through the principal axis, so if we draw a line and the light rays which it is passing through it, what it is going to happen? It is going to meet at a point. So, here it is going to meet it. This convex lens is also called as the converging lens. What is that? Converging lens. Then, concave lens, we call it as the diverging. Diverging means if you see the car headlights or the vehicle headlights, what it will happen? It is going to diverge. So, we call it as diverging lens. Concave lens is called as the diverging lens. Convex lens is called as the converging lens. And here it is having the double children. So we can call it as double convex lens. Double convex lens is also called as the convex lens, or we call it as the double convex lens also. Here also we are having the double. So the double concave lens is also called as the concave lens. Okay, so these are the two types of the lenses which we are having here. Okay, next let me see how to denote the lines on these lenses. Okay, now let me see through the which type of lens is this, children? This is the concave convex lens. Okay, so in this lens, the center of the lens, we call it as the center of that point. It is denoted by the letter O. It is denoted by the letter O. So if you mark the point of the center of the curvature. So here we can take the principal axis. So which the line is moving through the center of the O. We call it as the principal axis. This is called as the principal axis. Then here we are going to take the point on the principal axis. This is called as the center of curvature. So here we are having the two center of curvature. This is also called as the center of curvature. Then when the object is placed here, when the light is traveling, then these points we call it as the aperture. Where is this? This light, that is the center of that lens which we are going to draw, we call it as the aperture. So when the light rays, which ray is this? This is called as the incident ray. The refraction takes place near the aperture and it is going to refract. It is going to refract. So the two rays which it is passing, it is going to meet at a point. So here we need the principal foci. Principal foci is denoted by the capital F. Where it is going to meet, that point we are going to denote it as the small f, that is the focal length. Capital F is the principal foci, small f is the focal length. So it is going to meet at a point. So meeting is nothing but converging. Meeting is nothing but the converging lens. So these are the points regarding this lenses. Okay.
We see the differences between concave and convex lens. Concave and convex are two types of lenses that possess variation in physical shape as well as their properties. The crucial difference between concave and convex lens is that a concave lens diverges the light rays that incident on its surface. On the contrary, a convex lens has the ability to converge the light rays passing through it. What is a lens? A lens is known as an optical instrument that either converges or diverges the light beam that incidents on its surface by using the principle of refraction. It is actually a piece of glass in an appropriate shape which is responsible for converging or diverging the light rays. It is molded in a way to refract the light rays in order to form an image. The power of the lens is defined in terms of a measure of convergence or divergence the lens introduces to the light rays that incident on it. Here we will see how a concave lens is different from a convex. Here are the comparison between the concave and convex lens. So concave lens is called diverging lens, convex lens is called as the converging lens. In concave lens, the center of the glass piece is thin while the edges are thick. In convex lens, the center of the glass piece is thick whereas the edges are thin. Negative, thus sometimes referred as negative lens. Positive, hence another name used for it is positive lens. It diverges the light rays. It converges the light rays on the side of lens from where the rays are falling, on the opposite side of the lens from where the rays are falling. Always forms virtual and erect image. Generally forms real and inverted image. Farther and smaller than the actual entity, nearer and larger than the original entity. Lens in human eye, microscope, telescope, etc. Flashlights of vehicles, lasers and peepholes of doors. Then, what do you mean by the concave lens? A concave lens is a type of optical lens where the surface of the glass is curved in an inward direction, making the center thinner than the edges. Its outer surface somewhat resembles a concave. When a light ray falls on the surface of the lens, then it bends the light rays passing parallel to the principal axis. Basically, the curvature of the lens is responsible for the direction in which the ray bends, the amount with which it bends and the material of formation. In a concave lens, the center is quite thinner than the edges. Thus, the curve is present in an inward direction. So, when the light ray passes through it, then despite bending towards a single point, it disperses. Thus, concave lens are diverging in nature. So, we can see the picture of the concave lens. In concave lens, the path of the rays is traversed behind the lens so as to get the focal point. As the rays diverge in the case of concave lens, thus their focal length is negative. So here we can see the focal length. Then let me go for convex lens, a type of optical lens whose surface is bulged in an outward direction, making the center thicker than the edges. We have already discussed that when light forms the object incident on the surface of the lens, then it gets bent. Also, the direction of the bending depends on the curvature of material. So, as in the case of the convex lens, as the center is thicker than the edges, thus the ray of light passing through it bends in an inward direction towards a single point, thereby giving rise to the convergence lens of light rays. Hence, this is called as the converging lens. So, here we can see the figure, axis and also the focal point. So, this is the convex lens. The single point towards which the rays bent is the focal point. Thus, in this case of the convex lens, the focal point is present on the opposite side of the region from where the rays are falling. Thus, its focal length is positive. What are the key differences between the concave and convex lens? The key factor of differentiation between a concave and a convex lens is that a concave lens diverges the light rays that travel parallel to the principal axis, as against the convex lens converges the light rays that incident on it along the direction of its principal axis. Due to the nature of the lens, the incident light rays either converges or diverges after passing through it. Thus, the concave lens is also known as a diverging lens, while the convex lens is known as the converging lens. These two lenses are also differentiated on the basis of the shape possessed by them. A convex lens exhibits a cave-like structure from the outside as it has the thinner middle portion and thick edges. However, in the convex lens, the edges are comparatively thinner than the center of the lens. The polarity of the focal length is negative in this case of the concave lens, while it is positive for the convex lens. Due to this, the diverging lens sometimes referred as the negative lens, while the converging one is referred as the positive lens. The image from the concave lens is always virtual erect, while the real and inverted image is formed from the convex lens. However, in case of the object is very near to the lens, then the resultant image is virtual, erect and magnified. Lenses are used for the correction of issues related to vision. The concave lenses is used to cure myopia, while the convex lens corrects hypermetropia. Convex lenses hold magnifying abilities, thus are generally used in the lens of microscope and telescope. Also, the human eye lens is concave in nature, but a convex lens is used in lasers, flashlights of vehicles as well as peepholes of doors. In the case of concave lens, the body or object near it appears to be present at distance and is smaller than the actual one. However, when a body is present in front of a convex lens, then it appears in a way that is present nearer and is of larger dimensions than the original body. Now let me come to the conclusion. Thus, the above discussion between a concave and a convex lens concludes that both have different physical shapes and generates a different form of images when light rays incident on it, thus have the different applications. Okay, thank you children.